So good evening. I am Somak Nag, a research scholar at School of Mathematics and Statistics, University of Hyderabad. Today I will solve a problem from assignment 10 of previous year. So let me first show you the question. Questions are question number 7. Uh, is this visible? Question number 7. Rovi, you please respond.
Yes, sir, getting sir visual.
Okay. The problem is this, that about obtaining the formal solution of the mixed type boundary value problem for Laplace equation. You have to find by the method of separation of variable. The problem is given as Laplacian u is 0 together with a boundary condition of mixed type, means Dirichlet and Newman both. U of 0 y is 0 and u x1 y is 0. Uy x0 0, uy x1 is hx, where x and y lies between close interval 0 and 1, and h is a smooth function. So question number 7 tells that in the separation of variable method, a family of pair of ODE is obtained by substituting these separations u xy equal to x into y, where x is a function of x and y is a function of y. So you have to find the boundary conditions satisfied by x. So let me first write the equation, and let me write the equation first. So problem number 7, the Laplace equation by method of separation of variable. So the equation is Laplacian u is 0. Laplacian u is 0 when x and y lies in the x square region, open interval 0 1 plus 0 1, together with the conditions are y is in close interval 0 1, uy x comma 0 is 0, and uy x comma 1 is hx, where h is a h is a smooth function, where h sorry h real valued function, মানে it takes value on the real line. Okay, so now I'll solve using separation of variable, as they are saying we have to find the boundary conditions only. So you know that separation of variable method tells that u x y you have to put as function of x into function of y. Then my Laplacian of u, that is ux is what? Can you tell, Robi? Then ux, hello, hello, can you tell? Just differentiation with respect to.
Uh, yeah.
Hello, you can try, otherwise I will tell. Okay, I'm telling ux is just differentiation with respect to x. So here y is another independent variable, so no need. So only differentiation of with respect to small x. Y of y remains same. Uxx is similarly only differentiation with respect to small x. And y of y it remains fixed, same thing, whatever it is. Similarly, uy is only differentiation with respect to small y, so it is x remains constant into y dash of y, and uyy is xs into y double prime. So now I will put it uh, in the in the equation. Okay, so next page is I think this is next. Okay, okay. So huh. So Laplacian u is 0 means uxx plus uyy is equal to 0, right? So what is ux? I got x double prime x into yy plus uh, plus xx to y double prime y equal to 0. Now I will just reformulate it, that is x double prime x by x is equal to minus y double prime y by uh, up to this it is clear. This is equal to, up to this is it clear? Hello.
Yes, sir. Getting, sir.
Okay, so can you tell what should be this? This is function of x, right? Left hand side, and right hand side is a function of y, right? Everything is x, small x, and right hand side is just function of small y. So can you tell what should be these ratios are? What are these ratios? Is it constant or
Sir,
variable?
-1, no?
No, not minus one. Why minus one?
Uh, Constant -1, it's a.
No, no, constant. These are constant
Sir,
because
yes, sir. Constant, sir. Constant.
constant I take as lambda. Lambda is a constant. So because left hand side is a function of x, right hand side is a function of y, x and small y. So x and y both are independent variable. So they are function of x and equal to some function of y. It is happening. So it is only possibility is that it is equal to a constant. That is function of x equal to same constant, function of y equal to same constant. Then we say that function of x equal to function of y. Okay, is it, you got my point?
Yes, sir. Good, sir.
So okay, so equation, let me first write down the equation for x, then I will solve the boundary, that question. I will show you the question again. So equation of ODE for x, sorry, equation of ODE for capital X, it is, what is this? It is x double prime x minus lambda x x equal to 0, right? It is equation for capital X. I just took the first part, first ratio equal to lambda. Okay, this is the equation. Now I will show you the question. Question is question is you have to, which one of the following is the set of boundary conditions satisfied by capital X. So you have to find the boundary conditions. Boundary conditions are given as this u function of, it is given as a u that at the point 0 comma y, ux at the point 1 comma y. So what is u? uh, u is, now boundary condition is, boundary condition is u0y is 0, right? And another is ux1y is 0 for all y in close interval 0 1. Okay, now I choose uxy equal to x into x and capital Y into y. That means u0y is x into 0 y of y, right? And ux means what? Ux means x dash at 1 and y. You got my point? You got this line, uh, Robi? x0 is 0 and x prime 1 equal to 0, because we are interested in non-zero solution. So capital Y of y should be not equal to 0, because if capital Y is 0, then we got u is 0, my small u, but we are interested in non-zero solution. So this is the boundary condition for x. So you understand. So let me first let me check which option. X0 0 and x dash 1 is 0. So option B is the correct option. Option B. Okay. Question number 7. You got, Robi? And
Uh, yes, sir. Doing, sir.
any question? You have any question from this? Then otherwise I will move to question number 8. Question number 8. Let me do it in next page. You got? Okay, fine. So question number 8. Let me show you. Question number 8 is this is, which one of the following is a collection of eigenfunction for the ODE in X? You know eigenfunction, eigenvalue, this thing. Robi, separation of variable method. You know what is eigenfunction, how to find eigenvalue and eigenfunction? Otherwise, I will tell, no problem. Okay, so I think I am starting. Actually, eigenvalues means you have to solve this equation for capital X with the use of this boundary data that I got here, x0 0 x dash 1 0, and find the non-zero solution for capital X. Eigenvalues means non-zero functions. Okay, though, so let me write the ODE for X. For ODE in X, what we got? We got that x double prime x minus lambda. Lambda is a constant. For which value of lambda we got non-zero solution. It is then lambda is called eigenvalue and the solution is called eigenfunction. Okay. For which value of lambda we got non-zero solution. Then lambda is for that value. Lambda is called eigenvalue and function is called eigenfunction. So you know how to solve this equation. This is just a second order equation, like this equation d2y dx2 plus minus lambda y equal to 0. This type of equation you know how to solve. Just you have to put you know auxiliary equation, trial solution, this type of thing. So auxiliary equation is that is, you have to put x equal to e power mx, then solve. Auxiliary equation is m square minus lambda equal to 0, right, Robi? M square equal to lambda, right? You know up to this. You are there in call. Yes, you are there. So okay, I will continue, no problem, no problem. M square. Okay, I think yes. Okay, fine. M square equal to lambda. So for the, we have to find non-zero solution. Okay, so only for lambda less than 0 we got non-null solution. Only for lambda less than 0 we will get eigenfunction or non-zero solution. Same thing, we will get non-zero solution. Okay. So I got that m equal to, so what is m in that case? M square equal to lambda, so m equal to plus minus I root over minus lambda, right? Lambda is negative, you understand this line, from m square equal to lambda to m. Lambda is negative, so root over minus lambda is makes sense, it is positive quantity, and that's why I put I, because imaginary will come. So what is my x? X is cos and sine function. This since imaginary number is there, so root over minus lambda x plus c2 sine, sorry, sine root over minus lambda x. Okay, this is my x. So you have to find the, now you have boundary condition at what, at x equal to 0 and x at x equal to 1 with derivative x dash. So you have to find here a capital X dash also. So capital X dash is just derivative, that is minus c1 root over minus lambda. Okay, now what is my boundary condition at that x at 0 is 0 and x dash 1 equal to 1. X0 equal to 0 means cos 0 is 1, so c1 is 0, right? Sin 0 0 only. And x dash equal to 1 means since c1 is 0, so I will write only this part, c2 root over minus lambda cos of root over minus lambda into 1. 1 I am not writing, equal to 0, right? Now c2, can c2 be 0? Can you tell c2 be 0 or not? C2 is, lambda is negative, so lambda is non-zero. Any idea? C2 is non-zero, okay, because if C2 is equal to 0, I got x equal to 0 because I already got C1 equal to 0, right? So capital X equal to 0 I got. So C2 should be non-zero because we are interested in non-zero solution. We are finding non-zero solution, okay. So C2 non-zero, that means cos root over minus lambda is 0. Cos of 2n minus 1 into pi by 2, it is 0 for every natural number n, for n belongs to capital natural number set. Okay, so what is my root over minus lambda? It is 2n minus 1 into pi by 2, right? For n belongs to natural number. So what is my lambda? Sorry, oh, next page. Lambda is, I got lambda is lambda equal to minus 2n minus 1 whole square pi square by 4. Just I square it both sides because root over minus lambda is there. Just square and taking minus. Then I got like this. Okay. Okay, Ruby. Hello. Are you getting this? Or okay, yes. Okay, fine. So I got lambda this. So what is my x then? X equal to x that depends on n. Okay, so I will write xn. Since I got c1 equal to 0 and c2 non-zero, so I will write c2 sine root over minus lambda, that is 2n minus 1 into pi by 2. So 2n minus 1, sorry, 2n minus 1 into by 2 into pi into x is there because c took sine root over minus lambda x. Now since what are the eigenfunction? Eigenfunction are this, except the constant term are the eigenfunction. So eigenfunctions are, the eigenvalues are this lambda. Lambdas are called eigenvalue. Eigenfunctions are sine 2n minus 1 pi by 2 x, where n belongs to natural number. This is the eigenfunction, the non-zero solution at the eigenfunction. Okay, so let me show you the options. So I got sine 2n minus 1 pi by 2 into x, that is option C. Okay, Robi, hello, Robi, you understand? Option answer option C. Answer is option C. Hello, Robi. Okay, I think yes. Yes, okay, thank you. Uh, so next question is question number 9. I will show you the question. Question is uh, okay. Question number 9 is visible. Which one of the following is a formal solution of the given boundary problem? Same problem. I got up to x. Now I have to find capital Y n. Then the solution will be given in terms of yes. Okay. Okay. So question number 9 is that you have to find the solution by the separation of variable method. Already half part has been done. Then the next half part is you have to find the solution for y. So let me directly write the equation for y. Equation, one ODE equation, that is equation for y, that is, let me show you again. Y is y double dash by y equal to minus y double dash by y equal to lambda. So y equation is y double, I will write yn because I will tell you why, because I am taking these values of lambda, because lambda depends on small n belongs to natural number. Okay, lambda because depends on small n, so I will put these values of lambda for which I got non-zero solution. Okay, that's why I put yn. Lambda depends on n, that means y also depends on n. That means yn, what I got as lambda is 2n minus 1 whole square pi square by 4. 2n minus 1 whole square pi square by 4 capital yn y. Okay, so now the same process, same auxiliary equation you have to find. Auxiliary equation, that is m, say let's denote it as m1. So m1 square minus 2n minus 1 by square pi square by 4 equal to 0, right? So what is m1? M1 is just, this is a positive quantity, everything is positive, so there should not be any I, imaginary part. So plus minus 2n minus 1 into pi by 2, right? Is it okay, Robi? So I will write solution will be in terms of what? E power x or cos hyperbolic, anything. Cos or sine hyperbolic. Okay. Ruby. Next page. Next page I will write the solution. So what should be my yn? Yn of y is what? It should be uh, in terms of this is a real number plus minus real part. So it should be in terms of either you can write in terms of exponential of something, or you can write cos hyperbolic something plus sine hyperbolic. So I will write in terms of cos hyperbolic and sine hyperbolic. Okay. So yn y equal to a n. A is a constant that depends on n. A n cos hyperbolic, this thing 2n minus y 2n minus 1 pi by 2 into y plus bn sine hyperbolic 2n minus, sorry, 2n minus 1 into pi by 2 y, right? Any question? This is 2, oh, sorry, this is 2n minus 1 into pi by 2 y. Any question up to this? This is sine hyperbolic and cos hyperbolic function, so I will put bracket here, sine hyperbolic of this thing. Okay, this is hyperbolic. So what should be my un? Un means, since because everything depends on small n, that's why I put un. Unx is same xnx into y and y, right? So what I got as xn I got some constant into sine 2n minus 1 pi by 2 into x. So I will write what is xn, that is some another constant, say cn into sine 2n minus 1 pi by 2 into x. Okay, and what is yn I got in the above expression. Just I will write just the same thing, cos hyperbolic 2n minus 1 pi by 2 y plus y, okay, plus bn sine hyperbolic 2n minus 1 into pi by 2 y. Okay, and close the bracket. So I am multiplying this Cn into capital N. I am putting it as An dash, new name. Cn into An, capital N. Okay, An dash cos hyperbolic 2n minus 1 pi by 2 y plus again Cn into Bn equal to Bn dash. Say another constant sine hyperbolic 2n minus 1 pi by 2 y. Okay, so into sine 2n minus 1 pi by 2 x. Okay, so this is into sine 2n minus 1 pi by 2 x, right? So what is my u? You know that u is, what is u? Can you say u is what? U is nothing but the summation of this. U is nothing but this summation of that of x and x and y on y, this product. Okay, Robi, this is the method of separation of variable. U is this thing. Now I will put the value, I will put summation only, and the rest part is same as x and x into y and y. I just calculated. What is an dash cos hyperbolic 2n minus 1 pi by 2 into y plus bn dash sine hyperbolic into, this is total whole bracket, into sine 2n minus 1, sorry, sine 2n minus 1 pi by 2 into x. Okay, this is my u. This you have to find, Ruby. Oh, so I will show you the question, that is what is u, which one of the following is a formal solution. Now there, oh, now you have to, now sorry, now we have to use boundary conditions to find the value of an and bn. Okay, so what are the condition given? Condition is given as, let me show you the question again. I wrote condition given as uy x comma 0 is 0 and uy x comma 1 is hx, right? Now uy, you have to find then uy and differentiation with respect to y. So what is uy x comma y? Can you tell, or I will write? Term by term differentiation. Ruby, what is the derivative of cos hyperbolic? I will tell otherwise if you respond, if you know. Okay. The derivative of cos hyperbolic is sine hyperbolic, and derivative of sine hyperbolic is cos hyperbolic. Okay. So you have to differentiate with respect to small y. So small y is there only here and here. So as cos hyperbolic and then sine hyperbolic. So I will differentiate. So n dash into cos hyperbolic derivative is sine hyperbolic. So the product, this will come in front into sine hyperbolic plus bn dash into the what should I say, the coefficient of y that will come from into sine hyperbolic derivative is cos hyperbolic. Whole bracket close into sine 2n minus 1 pi by 2 into x, because we are differentiating with respect to y, so x will be treated as constant. Okay, so now I will put the I will put the conditions. Condition are given as uy x comma 0 is 0. Okay, so we have to put y equal to 0. So what is y equal to 0 tells what is cos hyperbolic 0, you know, Robi? Oh, sorry, what is sin hyperbolic 0 and cos hyperbolic 0, Robi? You're typing, or let me check once. Yes, possible. Okay, okay. It is 1 and 0. Yes, perfect. For cos hyperbolic it is 1, and for sin hyperbolic it is 0. Okay, actually I am not able to see your chat. That's why I have to come here. Uh, okay. Now, h sin hyperbolic, what is this? The derivative of sin hyperbolic is cos hyperbolic. Okay, so it is 1 and 0, so you are right. So the sin hyperbolic 0 is 0, so this is 0, plus cos hyperbolic 0 is 1, so bn dash into 2n minus 1 pi by 2, that's it, up to this. X is remaining, x sin 2n minus 1 pi by 2, x equal to sorry, equal to 0. So what I got, let me finalize, bn dash into some constant into sine of this. Now can you tell what is the value of bn dash from this? Just can you tell what is the value of bn dash? Uh, so let me show the chat. Yes, no, it is not there. Ruby, what is the value of bn dash from this? You have any idea? Anything? Otherwise, I will tell. Anything? You know anything about any idea about Fourier coefficient, Fourier series? Summation an cos nx plus bn sin nx equal to fx. So what are an and bn? An equal to 2 by length of the interval integral lower limit to upper limit fx cos nx dx, right? You know this thing, bn equal to 2 by the length of the interval lower limit to upper limit fx sin nx dx. You know this Fourier's coefficient, Fourier series. Robi, you know? Please response. Okay, I think you wrote something. Yes, okay, fine. By using this Fourier coefficient, we have to find this. So here my fx is 0, right? And my an is also 0. Small an is not here actually. Small an is not here, and only bn sin nx is there. So let me just sorry, just bn sin nx, bn sin not an. This is 2n minus 1 into pi by 2 x equal to fx, but my fx is 0, so what should be my bn? Bn dash is 0 in that case, because my f is 0, right hand side is 0, integral of 0 is 0. Okay, integral of 0 over f over it is a definite integral, then it is 0, otherwise it is a constant if it is an indefinite integral. So I will write, so I got bn dash equal to 0. Just 1 second, take time I think. So, okay, finish. Okay, so sorry, let me, yes. So I got my b and dash. So b and dash equal to 0 because of Fourier coefficient. Calculation is same as Fourier coefficient. So what is my now my another condition is uy at x comma 1 is equal to hx, not 0. So since I got b n dash equal to 0, this portion is 0. So only a n dash portion will be there. So that is summation a n dash into something 2n minus 1 by 2 into pi sine hyperbolic. This thing is 2n minus 1 by 2 pi. I think it should be something. Y equal to 1 I am putting. Okay. You just look at here uy x comma 1 and b n dash I have got already 0. So a n dash into this into sine 2n minus 1 pi by 2 into x that I got equal to hx. Here h is a real valued function, so it is not true that h is 0. So I got a n dash as non-zero, right? By Fourier coefficient, I will got a n dash equal to that thing 2 by that length of the interval is 1 because we are dealing with closed interval 0 to 1. Okay, so 2 by 1 integral lower limit to upper limit uh, hx into sine 2n minus 1 pi by 2 into x. Not only a n dash, I will got to, this is the whole constant a n dash into 2n minus 1 pi by 2. So I have to write 2n minus 1 pi by 2 into a n dash, the whole thing. This equal to, so I got a n dash as non-zero quantity. So the series is there. So I will now so I will got the answer here. So my answer is uxy is only a n dash term is there, b n dash term is 0. So let me write what is uxy. Uxy is summation a n cos hyper a n dash or a n anything a n cos hyperbolic 2n minus 1 pi by 2 into y sine 2n minus 1 pi x by 2. Okay, so this is my answer. So let me show you the question, answers. I got sine, cos hyperbolic and sine. Cos hyperbolic and sine is here. Cos hyperbolic sine is here in option number F. Cos hyperbolic and sine and 2n minus 1 pi by 2 x into y. Okay, so answer is F. Okay, Ruby. Answer is F. Summation n equal to 1 to infinity. Answer is sorry. Answer is F, capital F. Okay, it is clear for you or you understand? Okay, I think somebody wants to join or okay, Ruby. Yes, okay. Okay, so I'll show you the next question. Next question is this is I got the series. Next question is question number 10, that is you have to find the expression for an. Here it is written small n. Mine is capital N dash. So small as n is nothing but just now I write now here capital N dash. So a n dash I have to find. So I just already got this. So I will write in the next page. My a n dash is question number 10. You have to find the value of what is a n dash. So I got this expression. I'm just copying and writing a n dash or 2n minus 1 pi by 2 sine hyperbolic 2n minus 1 pi by 2 equal to 2 by length of the interval is 1, integral 0 to 1, right hand side is hx sine 2n, sorry, sine 2n minus 1 pi by 2 into x dx, right? This I got here. Here I think this is that whole constant 2n minus 1 pi by 2 sine hyperbolic is also there. So sine hyperbolic something. Okay, let me just rewrite this line. You are saying something or somebody wants to join? Let me check first. Oh, Ruby. Okay, no problem. The whole constant I am writing it here. 2n minus 1 pi by 2 sine hyperbolic 2n minus 1 by 2 into pi. This is the whole constant into a n dash. So I am getting a n dash is this. So what should be my a n dash? A n dash is just I am changing 4 by 2n minus 1 pi into sine hyperbolic 2n minus 1 by 2 into pi into integral 0 to 1 hx this thing sine 2n minus 1 pi by 2 into x dx. So this is my an. So that's why I got the answer. Answer is here gx is not there. It should be hx. This is a small error. So answer is 4 by 2n minus 1 into pi sine hyperbolic hx. This option B. Option B is my answer. Okay, fine. So option B is the answer. Okay. So option B is the answer. So answer is option B. So let me show you the next question then. Next question is question number 11. 11 is that you have to use okay. Okay, Ruby. So next question number 11. You know is it visible? Okay. Oh, yes.
Yes, sir.
Okay, fine.
Uh,
The question number 11 is different. 11 to question number 14, they are different questions. Okay. So question number 11 is that, sorry, let me show you the question. That d be the dx and u be the solution of this boundary value problem, Laplace equation with uxy is this on the boundary. Uxy is x square into 9 plus 4x plus 4y. And you have to find the value of u at any other points. Okay, so you know Poisson formula for this, for Laplace equation. If you don't know, you can go through the lectures. You got their Poisson formula for the to finding the value of u at any other points in the inside that domain. Okay, so let me write the domain, that is x y in R2 such that x square plus y square equal less than 1, this region. This is a dx and u is the solution of this equation, Laplacian is 0 for xy in D and u is on the boundary. X square into 9 plus 4x plus 4y. Okay, for x comma y on the boundary. Okay, fine. So, you know anything about Poisson formula, Ruby? Otherwise, I will tell what is Poisson formula. Poisson formula.
Uh, Sir, I know, but I can't remember now.
Okay, I am telling, no problem. You have to find the value of u at any other point xi. Okay, that is formula is given as r square minus the xi. Norm xi means value from the origin of the disc. WD is the surface area of the unit surface area of unit sphere in d dimension in RD, and capital R is the radius of the disc. Integral of this boundary over the boundary. G is the initial what is sorry, G is the condition on the boundary. That is this my where I put this line. This is my G here. G of x. X is x comma y. That is G of x comma y. Okay. So G by norm of x minus this xi whole power d of sigma. D means the xi is in RD, from where this d is coming. X and xi are in RD, capital X and xi. Okay, Robi. So here you have to find what you have to find. You have to find the value of u. You have to find the value of u at minus 1 by 4, comma minus 1 by 4. That is my xi is minus 1 by 4, comma 1 by 4. I am going to the next page. So here my xi is here. Here d is 2 first of all, because x and y two variable. Acha. My xi is minus 1 by 4, comma minus 1 by 4. Somebody wants to join, I think. Just one second. Hello. So I am solving this problem, Sasank. I am solving problem number 11. Huh? Problem number 11 is
Yes, sir. Yes, sir.
okay, okay. Problem number 11 is you have to find the value of u. U satisfies this Laplace equation with boundary, with the value of u is given on the boundary. Del d means on the boundary. You have to find the value of u at any other point inside the disc. Okay. So you know Poisson formula, Sasank. You know Poisson formula to find the value of u at any other point on the disc. So here it is written Poisson formula. Huh? Let me write what is WD. W of D is that surface area of unit sphere, say, in RD, that D tuple. Okay. So here my xi, I have to find the value at any other xi. Here my xi is minus 1 by 4, comma minus 1 by 4. So let me put this in the formula. Then we got the answer. So just u at minus 1 by 4, comma minus 1 by 4. This is equal to my r, capital R square, minus here. Oh, first of all, here capital R is 1, because R means the radius. Radius is 1. X square plus y square equal to 1. Less than 1 means the radius is 1. Okay. So here I got R square. I will put R equal to 1. I will put R equal to 1 later, after some calculation. So my xi is minus 1 by 4, comma minus 1 by 4. I am just putting in the formula. What is, can you say what is the surface area of a unit sphere in two dimensional? 2 pi r, right? Now unit sphere means small r is 1. So that should be 2 pi. Understand? into capital R. WD is 2 pi. Okay, surface area of unit sphere. Unit sphere means radius is 1. So WD is in a d in small d equal to 2. WD is 2 pi. So 2 pi r integral of the over the boundary. My gx is x square into 9 plus 4x plus 4y by what is my x norm of x minus xi power d, that is norm of capital X is x comma y minus xi is 1 minus 1 by 4 comma minus 1 by 4 whole square. D is 2. D of sigma, sigma means the on the boundary region, a portion. So this is r square minus this norm means distance from 0 0 origin. Okay, so this distance is 1 by 16 plus 1 by 16. This is square. So 2 by 16 means 1 by 8 by 2 pi r integral s is the s means on the boundary. Okay, everything is calculating on the boundary. 4x plus 4y by this distance, you know, x plus 1 by 4 whole square plus y plus 1 by 4 whole square. Is not it? Is it okay? This norm thing.
Yes, sir, correct.
Correct. Okay. Now here my capital R is capital R is the radius of this disc. Radius is 1, right? X square plus y square equal to 1. So capital R, I will put here R equal to 1. So I will put R equal to 1, that is 1 minus 1 by 8 into 2 pi integral s 01 into x square 9 plus 4x plus 4y by now it is on the boundary, huh? S01 means on the everything is calculating on the surface, boundary surface. So I am just deriving this square term, that is x square plus 2 into x into half. Okay, let me write x square plus y square plus x by 2 plus y by 2 plus what 1 by 8, right? Is it okay, this line? Just I expand this square. So what is on the boundary, what is x square plus y square? This is everything is calculating on the boundary. So on the boundary x square plus y square is 1, x by 2 plus y by 2 remains same plus 1 by 8 d sigma. Okay. So can you check that this 9 plus 4x plus 4y will cancel out from both sides, right? I'll show you in the next page, that is 7 by 16 pi integral s01 8x square 9 plus 4x plus 4y by 9 plus 4x plus 4y d of sigma. Just calculation. 8 plus 1 is 9. This 4x and 4y, right? This uh, numerator. Sorry, this denominator, right? So this will cancel out. Just you have to integrate of 8x square. So it is integral 7 by 16 pi integral over s01 8x square d sigma, right? It is integrating over the surface, over the boundary. So this is integral just 0, you know, I am putting x equal to cos theta and y equal to sin theta. So on the surface it is 0 to 2 pi 8 cos square theta d theta, right? So this integral is easy. 4 into 2 cos square theta means 1 plus cos 2 theta. I am just putting x equal to cos theta, nothing. And integration of cos theta 0 to 2 pi is 0. Okay, so 7 by 4 pi into 2 pi, that is 7 by 2 equal to 3.5. This is my answer. Is it okay? Is it okay? Ruby and here, Sasank. Hello. Do you have any question? So, is it okay for you? Otherwise, I will move to question number 12 and then 13, 14 is there. 13, 14 are easy. Question number 12. Question number 12 is same. You have to find the value of u at 1 by 4 comma half. Same formula, same thing. Okay. Just as the previous formula I will write directly then without by the same procedure. Just what is changing here? That changing is that I think region is also same. Region is x square plus y square less than 1. Only change is that this function g y square into 21 minus 8x minus 16y. Here it is x square into this. So again this term will cancel out by the same calculation. So by the same procedure we got u at we have to find at 1 by 4 comma half, that is equal to 1 minus same procedure. The 2 pi r is 1 integral what is boundary y square into 21 minus 8x minus 16y by the square is x minus 1 by 4 whole square plus y minus half whole square d of sigma, right? This is okay. Just I am directly writing this line, the last line of this page. This last line I am writing here with changing is my point 1 by 4 and half and my g function. So again I will calculate this. This is 11 by 32 pi integral s f01. So this is y square into 21 minus 8x minus 16y by what is x square plus y square is 1 on the boundary minus x by 2 minus y plus 5 by 16. You check, huh? Just check and confirm. 16y square 21 minus 8x minus 16y by this is again 21 minus 8x minus 16y to d of sigma. So this term will cancel out. Okay. So you got 11 by 32 pi. Again integral I am replacing y by y equal to sine theta. Right? X equal to cos theta, y equal to sine theta. This is the standard replacement from Cartesian to polar. So sine square theta d theta. Now sine square theta integration is q 2 pi is 2 pi. It's 8 into 2 sine square theta means 1 plus 1 minus cos 2 theta, and integral of 1 is 2 pi and cos 2 theta integral is 0. So you got it is 11 by 2, that is 5.5. Okay, this is my answer. Do you have any question? I am just doing the calculation, or you can do in your own. So the answer is 5.5. Okay, fine. 13 and 14 are easy. I'll do this. Do you have any question, Robi and Sasank, up to this? Tell me. If you have any question, you can ask. Robi is there only. Okay. Then I'll move to problem number 13. Okay, so I think I should. Okay, so problem number 13 is, let d be the dx, same dx, x square plus y square less than 1. U is a solution. U is a harmonic function. That means U is a solution. Laplacian U is 0. U is 2y plus 2 on the boundary. X square plus y square equal to 1. Then value of U at 0, 0. You have to find. So what is equation? Sorry, question number 11 is that. Question number 13. Question number 13 is that U is Laplacian U is 0 and U equal to some y plus 2 on the boundary. Boundary is d, in d and on the boundary. So you have to find U on the origin. Now what is my d? You have to find this. So my U d is this region, center at 0, 0. This is my capital D. So you know mean value property, Ruby. Mean value property. You know this thing? Mean value property means value at the center is equal to average of the values on the boundary. Value. Okay, I think you type something. Yes. Oh, you know. Oh, great. So tell me what is. Can you tell? Can you unmute yourself and tell? Okay. Value. Actually, mean value property is value at the center of any dx of any region. Value at center. Okay. Let you are writing. I think. No, no. That is Lagrange mean value theorem. That is different thing. This fc f dash equal to fd minus f over g minus a, this is Lagrange's mean value property for this Laplace equation. This is different. This is for real analysis, and you are doing now partial differential equation. So mean value property from for the Laplace equation. This Laplacian U is 0. This equation. Okay. So I am writing mean value property is value at the center is equal to average of the value on the boundary. Uh, average of values on boundary. That's why you have given only the boundary value of U, y plus 2. Huh? So here where is my pin? Oh, okay, okay, sorry. So here value at the origin 0, 0. Value at center is 0, 0. Okay, center is 0, 0. Value at 0 is equal to average. Average means U at any on the boundary. What should I take? X equal to cos theta and y equal to sin theta, right? X equal to r cos theta and r sin theta. So my r is 1 here. Radius is 1. So U at cos theta, comma sin theta, d theta. Okay. This is the average thing. You know average of a function. Average, why I took 1 by 2 pi? Because my whole interval is from 0 to 2 pi. So average means by the total value. Total value is 2 pi. Theta, total value of theta. So U at the boundary is given as sin y plus 2, right? Here U is given y plus 2 on del d, del of omega. So y means sin theta. So U at sin theta plus 2 d theta. Now we have to integrate. Sin theta integration is minus cos theta and 0 to 2 pi, and 2 integration of 2 is 2 into 2 pi, right? So now what is cos of 2 pi means 1 and cos of 0 also means 1, and this is 4 pi. So this is 0 plus 4 pi So means 4 pi. So 1 by 2 pi into 4 pi, that is equal to 2. Okay, this is my answer. You have any problem, any question? This is easy problem. Just you have to find, you have to know this value, mean value property. Value at the center is equal to the average of the values on the boundary. Then you got v of 0 0. Okay, Ravi.
Yes, sir. Okay.
Okay, so last problem. Last problem is that same thing. Only here what is changing, you can you tell just quickly what is changing. You have to find the value at 0 0. You on the on the center. What is changing here? Changing is that this you notice this where my cursor is here and here. It is the only change, right? On the boundary value. You are writing, I think. Rad radius what you got? Radius is between 0 to no. Radius is not between 0 to 1. Radius is 1. The region is okay. Okay. Let me just in next page I will tell. Okay. This is the D domain. This is D. D means x square plus y square less than 1. But we are considering this is my D region. But this is del D, this boundary. So boundary is what? Boundary is those x y points such that x square plus y square is equal to 1. Radius is not in between 0 to 1. Boundary is this. Now every calculation you have, I am doing this integration on the boundaries. Here problem number 12, problem number 11, all this s01 means on the boundary. So I have to take radius 1. This is the boundary del D. Okay, Robbie, you understand? Yes, radius is 1. Huh. Now you tell me what is the, just you have to do the same mean value property here also. You have to find the value at the origin, at the center. What is the change? Changing is that only on the boundary x square plus y square equal to 1. This is the boundary. Only on the boundary the value of u is changing. Only changed. So you have to use the same formula, same method. I am just writing here question number 14. So the by the mean value property, mean value, you can check this property in your in the video lecture. Mean value property value of the at the center, it is average of the values on the boundaries. Average means 1 by 2 pi, mean total theta. Boundary is cos theta sine. That's why I put x equal to cos theta, y equal to sine theta. Huh? X square boundary means those xy such that x square plus y square equal to 1. So x equal to cos theta, y equal to sine theta. Okay. So my u is here in the question. Let me show you the question properly. Question is u is 2x square. So my x is cos theta. So 2 cos square theta I have to write. Okay. So 0 to 2 pi 2 cos square theta d theta. So that is 1 by 2 pi. 2 cos square theta means 1 plus cos 2 theta. And cos 2 theta integration is 0 on 0 to 2 pi. Okay. Into 2 pi. So it is 1. So 1 is the answer. So let me show you. Yes, the answer is 1. So this is the end of questions. Okay, so it is 7:14. Okay, fine. Any question, Ruby? Do you have any question? If you don't have any question, then you can leave. Thank you. Or if you have any question, you can